Welcome to the lecture Introduction to PIC Microcontroller Part II. In last lecture, we have discussed about data memory bank. So data memory is 4 kilobyte and it is divided into 16 memory bank or data banks. And each bank we can use to store data. The upper bank, that is bank 0 and bank 16, they are divided into two parts. The upper part is used as a general purpose register part and the lower part is used as a SFR, that is special function register part. These are called as a access bank. To address this data memory, one method is to use the BSR register. So this BSR register is 4-bit register and it is used for direct memory address. So 4 bits are used to store the number of bank register bank. So if it is bank 0, 0000 will be stored in BSR register, and if it is bank F, then 1111 will be stored in BSR register. So we can say that address of this register bank is stored in the BSR register, or BSR register is used as a pointer to this memory bank in direct addressing mode. But there are different methods to access these banks of data memory location. So the registers used to access this data memory, as we have seen, it is a bank select register. So this BSR register is used to store the 4 bits of 12-bit address of data memory. So data memory address size is 12-bit, and out of this 12-bit, 4 bits are stored in BSR register. This is the one method. And second method, for indirect addressing mode, file select registers, FSR registers are used to point to data memory. So FSR 0, FSR 1 and FSR 2 registers are available, and FSR is composed of two 8-bit registers, FSR H and FSR L. These registers are used to point this data memory, and these are used to hold the 12-bit address of data register. Let us first understand here how this BSR 4-bit register is used to point to data memory. So the address of data memory is 12-bit and BSR register is having 4-bit address. The 8-bit of address comes from the instruction. So the assembly language instructions are having 8-bit part of address of this data memory. So 8 bits comes from this instruction, direct instruction. Instruction will have two parts: opcode of instruction, that is operational code, which is fixed for instruction and provided by manufacturer, and along with opcode it has a 8-bit address part. The 12-bit address of this data memory is computed by considering 8-bit address from the instruction and 4-bit address from the bank select register. So total 8-bit plus 4-bit will get a 12-bit address of data memory location, and then it will point to particular address of this memory location. So this is how BSR is used to point to the memory location. So this is the one method generally used in direct addressing mode. The next is the status register of this PIC microcontroller. So the status register size is 8-bit, but 5 bits are used as a flag bits. Lower 5 bits are used as a flag bit. So here C bit, that is D0 bit, is a carry bit. So whenever the controller performs operation on 8-bit of data, and if carry is generated after the performing operation on MSB, then this carry flag bit is set to 1. If there is no carry, then carry flag is reset to 0. User can check this carry flag after performing operation. Then next is DC, that is decimal carry. So it is used or it is set when the carry is generated after performing operation on lower nibble, that is lower 4 bits. So after performing any operation like addition, subtraction, if carry is generated or borrow is required, after performing operation on lower 4 bits, then DC flag bit is set to 1, otherwise it is 0. The next is 0 flag. So if result of any operation is 0, then this 0 flag is set to 1, otherwise it is 0. The OV is overflow flag. If result overflows, the controller cannot store result in 8-bit register, then this flag bit is set to 1. The fifth flag is negative flag. It is used to indicate sign of result. If sign of result is negative, that means MSB bit is 1. It indicates that the sign of result is negative, then this flag bit is set to 1. If it is 0, it indicates that result is positive. So it is used for sign bit number operations. So these are the flag bits. User can check these flag bits to check the status of result. The next is I/O ports of this microcontroller. It has 5 ports A, B, C, D, E. The port A has 6 pin or 7 pin. For this particular microcontroller PIC 18F452, port A has 6 port pins. All other ports like B, C and D will have 8 port pins, and port E has 3 port pins. So total 33 pins are there. Most of the I/O pins are multiplex. That means they can use as a general purpose I/O ports, or they have assigned different functions. So 8 pins are there for B, C, D, but port A is of 6 bit and E is of 3 bits. The addresses are assigned to these ports, and each port has a special function register, that is SFR register, that we'll discuss afterward. There are trace register, TRIS register associated with each port to decide the direction of port. Then there are port register like port A, port B, port C, port D, port E register, which are used to write data to port terminal. There are latch register. So different registers are there, and these are called as a special function registers for ports. This diagram shows how these pins are multiplexed. Like port A pins are shown here. So RA6 can be used as an input-output port, but RA5 is multiplex. It can be used as an analog input for ADC. Then SS bar, that is select terminal, for SPI protocol, LVD in. Like different functions are assigned to this port pin. So most of the port pins are multiplex. These are the port pins of port B. Now, other ports are also available. These pins are not shown here. And port E is having 3 port terminals. Then supporting devices, peripheral devices available in PIC microcontroller. So here few devices are shown, like it has a timer, timer 0, 1, 2, 3. Then capture compare modules, 2 modules are there, CCP1 and CCP2. Then MS serial port is there, addressable UART port is there, parallel slave port is there, data E-square prom is there. So number of supporting devices are available in PIC microcontroller. Few devices are shown here. AD converter is there. So supporting devices are timers. Timers are associated with capture, compare and PWM models. This capture, compare, PWM models uses a timer, different timers. Then serial communication models are there like master synchronous serial port, MSSP. Addressable USART model is there. AD converter is there, parallel slave port is there, data is square prom is there. So these are the supporting devices available in PIC microcontroller. So just go through this timer module in brief. Detailed programming we'll discuss in next lecture. The timer 0 module can use as a timer as well as counter, and there are 8-bit or 16-bit timer counter models. 8-bit software programmable prescaler is available. That means we can divide a frequency and then it is given to timer model. Internal or external clock select option is also available. Then they will set the flag bits when it overflows, when the count reaches to FFH, it will reset to 00H. Age select option is also available for external clock, whether you want to increase the timer from low to high transition or from high to low transition. That option is available. That is for timer 0. Timer 1 is 16-bit timer counter and cannot be operated in 8-bit mode. Timer 1 is 16-bit timer counter and cannot be operated in 8-bit mode. Capture, compare, PWM models are also available. So it contains 16-bit register which can operate as 16-bit capture register, 16-bit compare register and PWM master slave duty cycle register. So three functions are there in CCP model. It can capture the input signal, it can compare input with the predefined signal, and it can generate a PWM signal also. Both models are identical in operation. Only thing is that a special event trigger is different for CCP1 and CCP2 models. Then master synchronous serial port model is serial interface, and that is used for communicating with other peripherals or microcontroller devices like E-square prom, shift register, display driver, AD converter. So this MSSP model operates in two modes: serial peripheral interface, that is SPI protocol you can use to interface E-square ROM or AD converter, or we can use I2C protocol. So both these protocols are available under this MSSP model of PIC microcontroller. Then special function register. So number of special function registers are available and they are stored in the data memory. So each block of PIC microcontroller has a special function registers like IO ports, interrupt, E-square ROM, serial IO, timers, capture, compare, analog to digital converter. So all these blocks need registers and these registers are special function registers. So this is the complete memory map, how the special function registers are stored in memory. So these are the special function registers of PIC microcontroller, that is TOSU, associated with different block. Here this TRIS register, TRIS registers are shown associated with ports of this microcontroller. Then latch registers are also available for each port. Port registers are available where we can write data to particular port. So this is the example of port register. Similarly, different registers are available for each block. These are capture, compare, model register. Timer registers are also available. So lot of registers are there, and we'll discuss about this register while discussing the function of particular block in detail. The special features are also available in PIC microcontroller, that sleep modes are there, watchdog timer is there, code protection is available, in-circuit serial program is available. That means whenever our IC is in circuit, we can download or erase our program. In-circuit debugger is also available. Whenever our program is executing in the controller, we can debug it. We can check the contents of register and memory location. So that is also available.